What world do you believe would have life if there were life elsewhere in the universe? The new James Webb Space Telescope is the most potent tool available to scientists today for the search for life. This powerful space observatory has already locked on a target and is producing encouraging results, despite the fact that scientists have been debating this issue for centuries. The Hubble Space Telescope, which has been sending back breathtaking pictures of deep space for 30 years, has been around for years, but none have come close to the new James Webb Space Telescope. In fact, it is 100 times more powerful. NASA claimed that the James Webb Space Telescope could see details as tiny as a US penny at a distance of about 25 miles and could even detect the faint heat of a bumblebee at a distance of the moon. Of course, NASA is not launching a $10 billion space observatory to look for bumblebees or pennies. Instead, the project is intended to provide a more complete picture of how the galaxy is formed and perhaps provide some answers to old questions about the origin of the universe. The Hubble Space Telescope is renowned for taking mesmerizing pictures of space, but it has a drawback. It can't let scientists see the very first galaxies that formed after the Big Bang. This is something that the James Webb Space Telescope will alter. Scientists will be able to examine light that has been traveling through space for up to 13.5 billion years, several hundreds of millions of years longer than the Hubble. You could say that NASA has installed a massive time machine in space. The James Webb Space Telescope's sun shield, which keeps it cool and is one of its most recognizable features. This cooling is essential for the telescope to operate as intended. The shield is the size of a typical tennis court, to fit into, and had to be pleated. The primary mirror of the James Webb Space Telescope is divided into 18 segments and covered in a gold coating so thin that a single strand of your hair is 1,000 times thicker than this mirror. It had to be folded to fit into the launch vehicle. The primary mirror of the James Webb Space Telescope is divided into 18 segments and covered in a gold coating that is so thin that a single strand of your hair is 1,000 times thicker. The Hubble Space Telescope has been visited numerous times for repairs and part changes. But of course, the Hubble is only 340 miles away, or the newer telescope is located 1 million miles away. So the James Webb Space Telescope mission is literally beyond repair. Depending on how you look at it, it's not practical to send a crew in for a repair because it's so far away. It can't even be refueled as of now. It's a $10 billion bet. While the James Webb Space Observatory is currently being built, this powerful observatory will assist scientists in their research of exoplanets, or planets outside of our solar system, before the James Webb Space Telescope is launched. Scientists were particularly interested in one exoplanet, but had to wait for the James Webb Space Telescope to be able to study it in depth because exoplanets were very difficult to even detect, let alone study. Before discussing which exoplanet scientists are most eager to study and why, it is important to understand why exoplanets are so challenging to find and study. The first reason is that exoplanets are so difficult to detect and study because they orbit stars that are too bright to see the orbiting planets. The second reason is that exoplanets orbit stars that are too far away for astronauts to travel to. It's similar to attempting to observe distantly. The light from a star temporarily dims as a planet passes in front of it during its orbit, so scientists had to develop other techniques. The transit method, used by the Kepler Space Telescope to find exoplanets, allows them to be identified and their sizes and orbital periods can be calculated. The James Webb Space Telescope will make it easier for astronomers to find exoplanets, and one of the exoplanets they are anxious to study is Proxima b. In fact, the majority of exoplanets discovered were discovered using this technique. The most fascinating aspect of Proxima is how much it resembles Earth. This is what makes it unique. Using a shell spectrograph, the rocky exoplanet, steady spectroscopic observations, or espresso, researchers were able to determine that this exoplanet, which is only 4.2 light-years from Earth, is only 17 more massive than our planet. There are some facts discovered by a research team that strongly indicate that Proxima b is showing signs of life. Currently mounted on the European Southern Observatory's ESO, Very Large Telescope in Chile, Espresso is a Swiss spectrograph that observes objects and separates the light emanating from those objects into the constituent wavelengths, allowing researchers to study the object in greater detail. Proxima is an uncommon word. The mass of the recently discovered planet, known as Proxima b, was precisely determined to be over 1/10 of the mass of Earth in 2016 thanks to the use of espresso. However, Proxima b's orbital position in relation to its star, Proxima Centauri, which is the nearest star to our Sun, is even more intriguing because it indicates that liquid water may exist on the planet. The exoplanet remains in the habitable zone despite being much closer to its star than the Earth is to the Sun because of the temperature, which makes water one of the requirements for life as we know it. Proxima orbits its star completely in just 11.2 days as opposed to the Earth's much longer orbital period. Proxima b is tidally locked to Proxima Centauri, which means that one side of the planet is permanently facing the star and is therefore permanently dark, and the Earth and Moon are in the same cosmic relationship. Proxima receives roughly the same energy from its star as what the Earth receives from the Sun. If Proxima b has an atmosphere, it may be necessary for the exoplanet to have one in order to defend it from potential threats. This is one of the things that scientists will be able to confirm using the James Webb Space Telescope. There is another indication of life on Proxima that scientists are hoping to study. The James Webb Space Telescope will be very helpful in this regard. In fact, this is one of the most conclusive indications of extraterrestrial life on an exoplanet. The idea came from the fact that Proxima b, as we said earlier, is tidally locked to its star because one side of the exoplanet is always dark. The Harvard, according to astronomer R.V. Loeb, intelligent aliens could be using artificial light to illuminate their surroundings, much like how we would turn on a light when it gets dark. These artificial lights could be obtained through strong mirrors or extremely bright LED-style lights. All we have to do is find a way to capture these bright lights. We can confirm that there are aliens on the exoplanet, and this is where the James Webb Space Telescope comes in. However, is it really possible that aliens will choose to stay or be active in the dark parts of the vicinity B? After all, Chinese scientists recently managed to land on the Moon's permanently dark side. LOPS suggests that we can detect this artificial light by using the near-infrared instrument on the James Webb Space Telescope and looking for the telltale signs of LED light waves in the light from the planet and its host star. Who knows what the aliens on Proxima are doing in the darkness of their home planet? The professor has spent more than a decade speculating about the existence of aliens and offering suggestions for how they might be found. He is also a member of the groundbreaking Starshot project, which aims to send laser-boosted light sails to the Proxima Centauri star at high speeds, reaching this star in decades. The astronomer also claimed in a paper that the interstellar asteroid Oumuamua was humanity's first contact with an artifact of extra. He is currently focusing on Proxima b, which many alien hunters believe to be a top candidate in the search for evidence of intelligent extraterrestrial life outside of our solar system. He is relying on the James Webb Space Telescope to gather all the information necessary to support his theories. According to Loeb, his team took into account a variety of situations, such as artificial illumination that has the same spectrum as LEDs that are frequently used on Earth. This theory of artificial light requires an optimal performance from the near-infrared spectrograph or near-spec instrument on the James Webb Space Telescope to come to the conclusion that it may be able to detect artificial light. They realized that the James Webb Space Telescope can detect LED-type artificial lights making up 5% of stellar power. James Webb Space Telescope was utilized by Logan's peers. Calculator for exposure duration. This is a tool that enables astronomers to forecast what can be observed in any given time period based on previously defined settings. Before the observatory launches, It allowed them to assess the possibility of detecting various flux values and detecting those with a wavelength that corresponds to artificial light levels that should be anticipated from a civilization living in perpetual darkness on Proxima b. What do you believe about aliens? So that's it for today. Hope you like this video. If you really then, make sure to subscribe to our channel and hit bell icon for more type of that content. Thanks for watching.